if you're wondering what's happened, so am I. The computer that we have running our news from time to time took off and went wild. So what we're going to do is start over from the top. If you're wondering what's happened, so am I. Let me hear you say, get louder.
Hello everybody and welcome to the live stream today. Today we're going to start covering Module 5, which is a beginning look at iteration, and we'll talk more about what that means in terms of the big picture here in just a moment. But first of all, I think a little bit of an apology is in order. I made a little bit of a goof on Friday when I made my weekend announcement, and I accidentally put the wrong module number. It looks like the majority of you were able to, you knew what was up and just completed the work that you were supposed to have completed, and that's great. The vast majority of you didn't have to worry about any extra effort. I am human after all, and I just hit the wrong number. Believe it or not, they're side by side on the keyboard. So sometimes you make a little goof like that, but just remember that the thing that overrides everything is the thing that's in the Begin Here module and the syllabus. We have that module due date layout section there that gives us sort of a timetable for our when things are due for each module. So if you ever have questions, if you ever, think maybe he made a mistake, maybe he meant this or that, that's a good place to check. Another good thing to do is to ask me. Because, again, I am human, make mistakes. So just shoot me an email and just say, hey, did you mean that? And I might say, oh, no, I didn't mean that. And we can correct everything and get everything done. But it looks like the vast majority of you handled it just fine. And if you ended up working ahead and getting this module done, well, you're pretty far ahead. And if you'd like me to reopen those assignments for you for this current module, for Module 5, because you submitted it early before hearing the module material. Just shoot me an email and I will I'll reopen those for you. But we're talking about while loops today. And hopefully this is going to be a bit of a shorter live stream. The last two live streams are really, I think more than the last two live streams were over an hour in length, and I don't really like them to be that long. You know, I like these to be manageable in general, but the last couple were over an hour. So I'm hoping today's could be maybe a little shorter. So we're just going to talk about the concept of while loops and do just a little demonstration for you all on while loops. And then next week in our second live stream of the module, we will do a little more with the while loops. But so the module's called iteration. But the only iteration that we cover in this module is the while loop. It's a really introductory level introduction to iteration as far as all that goes. And, you know, if you're reading all of this and you're working through this and you're saying iteration, I've programmed before, I know more about iteration, like I know this and that. If you're not, we go into a little more iteration with some other stuff in the next module. When we look at string manipulation, we'll look at some for loops and some other stuff in relation to that. So we've got more to discuss in relation to iteration, so it doesn't stop here. Just to get us started, we're starting with the idea of while loops. So let's start out by talking about what is a loop. So what a loop does is a loop allows us to repeat a process until a condition is met. Now, that might sound familiar to you. Because, back a couple of modules ago, we were talking about something called recursion. And by a couple modules ago, I mean the last module. We were talking about the idea of recursion. And recursion being, where we would invoke a function within itself, allowing that function to essentially loop over and start again. And we would say that when this happens, that that we would have a recursive invocation, or that function would recurse. And so in doing so, it would repeat a process. And we would do this recursion in conjunction with our conditionals. Our conditionals being our if statements. If x is greater than 3, then we could do something or other. And we were talking about how one of the things that we would want to do if we were doing recursion is we would want to take whatever value we were working with in our condition and move it toward the case that would actually break the condition. So if our condition said x is greater than 3, we would have to do something to x each time we recursed the method. We recursively invoked the method to try to move x toward breaking that condition. So each time we would invoke that function name, whatever we called that function name, maybe we would recursively invoke that with x minus a value like 2 to try to bring it closer to breaking that condition. So when we're talking about looping here, and we're saying that a loop allows us to repeat a process until a condition is met, that statement on its own should sound very familiar to you. But in contrast to our recursion, where each repetition through the process is a recursive invocation or something of that nature, each step through a loop is called an iteration. So we use some different terminology for when we're dealing with recursion versus when we're dealing with loops. And if you'll think back to when we were discussing recursion, I even mentioned the idea of iteration. And I said that we could do pretty much everything that we do with recursion with iteration. And I told you to keep the idea of iteration in the back of your minds, that we'll get to it and we'll talk about it later, but we weren't going to talk about it right then. We're talking about it now. And we're talking about iteration in relation to these loops. So what we're doing here is we're just running through an input and applying the same conditions to each part of it in a similar fashion to what we were working with when we were working with our recursion earlier on. Just iteration makes it a little bit easier. One of the big examples here is sorting, and that's one of the things that we'll do perhaps a little later on down the line. We'll look at the different sorting algorithms. So put a pin in the idea of sorting for the time being, because we're actually going to take a deeper dive into sorting algorithms in the final module of the course, I believe. So we will just put a pin in the idea of sorting for right now, but just keep in mind that the idea of iteration and loops plays a huge part in sorting. So we're working with a while loop here. And the while loop, we start with the while loop in relation to learning to code and learning our programming logic, because it is the most similar to the idea of recursion. Because when we read these statements here about the while loop, then you'll see that it's really, really similar to the idea of recursion and how recursion works. Like, first of all, with a while loop, we can execute a set of statements as long as a condition is true. And so that's similar to if statements. You know, we're identifying this condition. If it's true, we're going to execute this set of code, and if it's false, we're going to skip it. And in Python, even more so than other programming languages, the while statement is even more like the conditional if statements that we're used to. Now, another thing here is that the while loop requires relevant variables to be ready. Now, we call this seeding the loop, right? Let me write that here on screen somewhere for you. We call this seeding the loop. In fact, it's been a couple days since I've made this slide deck. I might have made a slide to that effect. Let me... Flow of execution... Seeding... Oh, yep. So we'll put a pin in that, and we'll talk about it in a minute. The idea of seeding the loop requires relevant variables to be ready. Because we have to be able to start the loop. We have to be able to kick it off. But we'll get there in just a minute. So let's talk about the flow of execution for a while loop. So we're going to evaluate the condition. When we evaluate that condition, it's going to give us either a true or a false, just like an if statement. Whenever we take that if statement and evaluate the condition, it's going to give us either a true or a false. If the condition is false, it's going to skip that code that's related to the while loop, and it's just going to continue on. If the condition is true, it's going to execute that code that's related to that while loop. But then, unlike the if statement, unlike the conditional, it's going to go back up to the top and start again. So if we were to look at it like a diagram, it would look like this, right? So this is our while loop diagram. So we've got our input coming into our condition. As long as our condition evaluates to be true, we're going to execute the statements that exist within the loop. So since it's Python, it's going to be whatever code is indented underneath that while loop statement. And then once it executes those lines of code, it's going to go back up to the top and check the condition again. Now it's right here when we see the potential for us to get caught in an infinite loop. And we've talked about an infinite loop before when we talked about recursion. And we'll mention an infinite loop again as we progress through our slides today. But we can actually visually see our infinite loop appearing here in this diagram that we're working with. That's why we have to move our value toward our condition so that it breaks the condition, makes the condition false. So that when it makes the condition false, when the condition is false, it moves outside of the loop. Because as long as that condition is true, we're stuck in here. We're stuck in this loop. And it's going to do that forever and ever and ever and ever. And that's not what we want. You know, it's going to get us in that infinite loop like we talked about when we talked about recursion. Infinite loop leads to Stack Overflow, which Python has some infinite loop, anti-infinite loop error built into it. But it's an error that we don't want to see, so we can fight against that infinite loop by being aware of it. So we always want to make sure that we're working with our unit, whatever our variable is, whatever we're changing, to try to bring it closer to the condition, to break that condition, to make that condition false so we can break outside of our loop. Because out here is freedom. Freedom. But in here, you're just caught in a cycle. Eventually, you want to break out and get to freedom. So let's look at some examples. Let's look at an example here. So we have this example of a while loop with the syntax in place in Python. So this is what it looks like to write a while loop in Python. So let's take a moment and let's break this down. we have this variable here. This variable container. And we've given it the name of I. And right now, inside of that variable container, we've assigned it a value of 1. Now, one of the things about variables that we've talked about before is that we can change the value of a variable. It's a container. It's a bucket, right? Just like anything else that's inside of a bucket, we can reach in, we can take it out, and we can put something else in its place. We call the process of changing the value of a variable, we call that reassignment. We call that reassignment when we're changing the value of a variable. And the looping process, the iteration process, relies heavily on reassignment. And the example that we have here is no different. So we can kind of consider this through each process of the iteration. So through this first iteration, I equals 1. So we evaluate our statement in which we're essentially saying 1 is less than 6. As it turns out, that is true. So it's going to print the value of I, which at this point is 1, to the console. But then the next important thing is what comes after that. I plus equals 1. So plus equals in Python is like plus plus. If you're familiar with Java or C++ or some other programming languages, plus equals is our shorthand for adding 1 to, or in this plus equals 1. Plus equals is shorthand for adding something to itself. So if I were to expand this out, it would basically be like saying equals I plus 1. So that's our shorthand in this instance. So as we work through this, we get to that line after we've printed 1 to the console, get to this line of I plus equals 1. Now we've reassigned the value of I in our container, and now it's a 2. So then it will jump back up to the top of our while loop and evaluate the statement again with this new value of I. This statement is the most critical statement of our while loop, because this is the statement that is moving that variable toward that bound. If 6 is our bound, 6 is our limit, we're saying as long as our variable I is less than 6, we're going to do this. So then we have this line of code here that's saying we're incrementally moving this towards 6. So then we can check the second iteration through. And now it's a 2. So we're saying 2 is less than 6. As it turns out, yes, that's true. And so it'll print a 2 to the console. And then it'll take the value of our variable I and add 1 to it. So now at this point, the value in our container here is no longer 2. Now it is 3. So on and so forth. So then we jump back up to the top of our while statement. Evaluate the statement again. 3 less than 6. That just so happens to be true. And it'll print out 3 to the console. The value of I gets 1 added to it. So then the I gets reassigned to a 4. So now it's 4 is less than 6. Well, that's still true. So it's going to print a 4 to the console. I plus equals 1. So that value of I is going to get another 1 added to it. So now the value in our I container is 5. 5 is less than 6. That is still true. So it's going to print out 5 to the console. And we're going to execute that line again. I plus equals 1. So we're going to take that value that's currently in I, add another 1 to it. So now we're going to evaluate the condition again, but now it's 6 is less than 6. Uh-oh, that's not true. That is false. Because 6 is not less than 6. 6 is equal to 6. You can't be less than and equal. That's impossible. So with this, nothing will happen. This we've now taken our condition, turned it from true to false. And so once our condition goes false, that means that this code does not get executed. So when our code stops, the value of I is 6. And we've printed 1, 2, 3, 4, 5 to the console. And so that's the output that we see in the console is 1, 2, 3, 4, 5. We're counting up. And so we have two really critical lines here. The most critical, as we've already mentioned, being this one, because that's incrementing our variable to get it toward this upper bound so that we can stop that loop. But there's also this I equals 1. That has its own level of importance to it. Right? Because this gets into the importance of what we're talking about when we're talking about seeding the loop. So let's take into consideration that I equals 1 example. Right? We got that I equals 1. We want that loop to be able to start. Right? So we have to give that some sort of value for it to kick off, or else that's just dead code. So when writing a while loop, we have to give ourselves a starting place that's going to make that condition initially true. Whether we enter it in as a variable or whether we get it in as an input from our user or whatever. And we call this seeding the loop. And it is kind of a common kind of rookie mistake to create a while loop without creating a condition under which it will initialize. That's the big thing there, is having a condition under which this while loop will start to run. Because if you don't have a place where this while loop will run, then essentially your entire while loop is just dead code, and you're kind of out of luck on being able to take advantage of the things that your while loop has to offer you. So it's less than ideal. We want to have some kind of condition where we have some kind of starting value coming in, whether we assign it via a variable or we take it from a user or we get it somewhere. Because we have to kick off the loop. We have to start the loop and we have to end the loop. Those are the two most important things that we have to consider when we're dealing with our loops. I'd say the latter is more important, the fact that we have to end our loop. But, it is what it is. Speaking of stopping a loop, just like how we need to create a way to stop our recursive methods, we need to be able to stop our loops. The body of the loop should change the value of one or more variables so that eventually the condition becomes false and the loop terminates. Otherwise, we end up with an infinite loop. The infinite loop being just like we talked about for recursion, just like we've already mentioned here, so we won't spend a whole lot of time here. We have some other ways that we can stop our loop even if our condition is true. One of which is this break statement. With the break statement, we can stop the loop even if the condition is true. So in the example here, we've added an if statement into that loop that you saw before. While I is less than 6, print I, if I equals 3, break. So we actually have a conditional that we've introduced into our loop that's adding another level to it. So let's talk about what this is going to do really quickly. So we've seeded our loop with the value of I equals 1. So we're starting with I being 1. And we're saying 1 is less than 6. That's true. So we're going to evaluate our code that's within our loop. We're going to print I, so 1 is going to print to the console. Then we're going to check to see if I equals 3. It's not. So we're going to add 1 to the value of I. So now I equals 2. So 2 is less than 6. That's true. We're going to print a 2 to the console because that's the next thing that we have in the order of execution. Then we're going to evaluate this if statement to say if 2 is equal to 3, it's not. So we're going to skip that. And we're going to jump down to I plus equals 1. So that's going to turn it into 3. So 3 is less than 6. That's true. The next thing is to print I. So in that case, it is 3. And in this case, I equals 3. So then that we're going to break and stop our loop. Going to cut out. So we're not even going to get to that upper bound of 6. We're going to stop early because of this statement here. Once I equals 3, we're going to break and escape our loop. We're going to make a break for it. You know, it kind of gets back to that example of earlier. Like, once we escape our loop, it's freedom. In this instance, we're going to make a break for it and escape our loop and get to freedom. Right? So that's what we're doing here. In a similar way to break, we also have continue. With the continue statement, we can stop the current iteration and continue with the next. So just quickly in the example here, in this case, based on where our print statement is, we can go over this really quickly. We're starting out with I equals 3 or I equals 0 this time. So 0 is less than 6. Which is true. But we do have to pay attention to our flow of execution here. Because the first thing we're doing is we're adding 1 to I. Right? So at this point right here, I is 1 and not 0 anymore. Because it's the first thing we've done in the flow of execution. So now we're going to check to see if I equals 3. It doesn't yet. And then we're going to print I. So at this point, we're going to print 1. And then it's 1 is less than 6. Which that is true. That 1 immediately becomes a 2 in our flow of execution. if 2 equals 3, which it doesn't. So we're going to skip that continue. And we're going to jump to that print, which is going to be a 2. Go back up. While 2 is less than 6, which is true. I plus equals 1. So now I is 3. 3 equals 3, that's true. Continue. So we're just going to go ahead and jump right back up to the top of our while statement. We're not going to print out anything here because we're not going to get to that print statement here. Because we've hit this continue. So because we've hit this continue, we're going to stop this current iteration and jump back to the top and continue on with the next. So no 3. We're going to continue to our next. 3 is less than 6, which is true. 3 plus equals 1 makes that 4. So the next thing that would be printed to the console would be 4. So that's what we get there with our continue statement. So we skipped a number there like that. So it'd be an interesting way to skip odd numbers or even numbers. You know, you can use a modulo statement here and take an input and say, you know, if I modulo 2 equals 0, then continue, and then otherwise print I. So that way you're just printing out odd numbers. That'd be an interesting way to use that. Finally, we have an else. We can even utilize an else statement with a while loop, just like we can with an if statement. And we're actually going to do that in our example. With the else statement, we can run a block of code once when the condition is no longer true. So it'll run all of our code. It'll run all of the code in the while statement loop. And once you break that code, make that false, it'll run the else. Now, unlike the if statements, we can't use an elif. We can only use an else here. So that's all that we have for our slideshow today. So let us do a quick little example. So what I'm going to do right now is I'm just going to write a little countdown program. We're just going to do something relatively simple this week and save something a little more difficult for next time. Right, just like last time where we, when we had a 2-week module, we started with something simple on the first week's module, Livestream, and then on the second week's Livestream, we did a little more complicated program. That's the idea that we're going by here today. So we're going to start out with a simple little demonstration of a while loop, and we're just going to make a countdown program. So what I'm going to want to do is I'm going to want to write a program that counts down from a number to 1. And then after it hits that, print blast off. So we're like counting down the space shuttle launch. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, blast off, hypothetically. So that'll be our goal for writing this Python program today. So let's zoom in here. We'll start off with what we always start off with here, and that is our shebang. So let's enter our shebang here. Remember that we enter our shebang so that our interpreter knows which version of Python that we're using, which is especially useful if you're using multiple different versions of Python on your machine. Remember, it's not 100% required if you're using the online IDE, but we are doing it for best practice's sake, because when you're in a development environment, you're probably not going to be using an online IDE like this, or the development environment's rendering system might be just a little different. So we're going to make sure we include that shebang. And we're going to now then create our function, and we're going to call it countdown. Def countdown. And we're going to add a argument into our countdown definition here. I'm just going to call it X. And that's going to be the integer that we use to be our starting number that we're counting down from. That's also going to be our seed for our loop, right? So that's going to be our starting point. That's going to be how we seed the loop, is with this argument in our function. So when we declare this, when we invoke this function, we're going to invoke it with this integer as an argument. And in essence, that's going to be seeding our loop. So let's go ahead and write our condition for our while loop. So it's going to be while x is greater than 0. So in this case, we're talking about x being greater than 0. So something, integers greater than 0, remember, include all integers from 1 all the way up to positive infinity. So when we're thinking about this program, our x here could really be anything, right? So while x is greater than 0, we're going to print x. And then what we need to do is we need to iterate, or rather we need to move that x to where it would be closer to 0. So in order to move that x to where it would be closer to 0, what we have to do is we have to make that x smaller. So since we're counting down by 1, and we want to count down 10, 9, 8, 7, 6, 5, 4, or whatever, we're going to subtract 1 from x. So like in our previous examples, we could use plus equals. You could also use minus equals as a shorthand, and it works as well. So x minus equals 1, and that does our iteration for us. So now if we invoke countdown with a value of 10, 10 is greater than 0, it'll print 10, it'll take 1 away and turn it into 9. 9 is greater than 0, 8 is greater than 0, 7 is greater than 0, 6 is greater than 0, 5 is greater than 0, 4 is greater than 0, 3 is greater than 0, 2 is greater than 0, 1 is greater than 0, but then 0 is not greater than 0, so it'll break at that point and evaluate false and stop running. So let's add an else statement for what to do when that condition turns false. We want to print last off. So that's perfectly modular, perfectly good code. Now we can put this behind our main gate, so the actual invocation won't run if we were to try to import this into any other piece of software that we want to make. So if name equals main, we can invoke countdown with an integer value of, say, 10 in our argument. So this is a fairly simple program, and I'll kind of leave it here for just a second. If you know, if you're watching this as a recording, you know, it might be a good place to pause and get kind of caught up, because we're kind of done here with our program as it stands. So I can run this, right? And get the expected output. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, blast off. And whatever we put in as our argument here is going to change our countdown accordingly. And you might think, well, why can't we do that? Why can't we do that manually? Why can't we just type all that out? And you can, right? You could just type all that out. You could type in 10 print statements. But what I want you to see here is the efficiency, the effectiveness, the modularity, the flexibility of the way that we've done this here. Right? I can type any number here into this argument, and we'll take it a step further in just a second. But I can type any number into this argument, and it'll count down from that number, and it'll tell me blast off. It's completely flexible. I can use it in anything. It's a good basis for other stuff. Like, you can write this manually and just write print 10, print 9, print 8, print 7. But you're doing that, you're writing a line of code for each of those lines. And if you decide, oh, I want it to print from 20 instead of 10, or 5 instead of 10, you're having to go back in there and add or delete a bunch of lines of code instead of just changing one thing. And we could even extend this further by adding another function for our input. So we can add a def get input and give it, give it some kind of argument of, like, we'll call it info for the time being. So we'll set some kind of value of num equals int input info return num. Right, so now we can just enter that into our countdown area here. So we can get input and add our prompt as our argument. Enter starting number for countdown. Run that. Enter starting number for countdown. We'll enter in 15. And it gives us 15, 14, 13, 12, 11, so on and so forth. Blast off. And we can run that each time. Add a different number. Get a different output. We can even put in something big like 50. And let it go all the way down for us. So I said I wanted to have a bit of a shorter live stream today, and we've nearly gone 50 minutes, so that's probably enough. So here's where I'll stop for today. If anybody who is in the live stream chat with me today has any questions, feel free to ask them in the chat, and we'll answer them to the best of our ability. But this is getting started with our while loops for this week. Next week we'll extend on this a little bit, look at a few other things in relation to the Module 5 information. So what I'm going to do now is I'm just going to, if anybody in the chat has any questions, I'm just going to hang out with the music on for a couple minutes, answer questions if need be. Otherwise, that's all I have for today. If you're out there watching this recorded, feel free to send me a question via email. Thank you for watching, and we'll talk to you next time.
Let me hear you say, get louder.